Mr. Mac here. I'm going to do some of the solutions here for 5.1 practice. We're talking about mid-segments. And I think we're good to go here for the first, couple of questions. And so I want to start at 11. And we're going to do 11, 13, 14, and then on paper I'll do some of the coordinate geometry and the construction. So let's take a look at number 11. What do we got? We have a triangle here, and we've got these points are in the middle because we see the given hash marks that mark congruence. So let's see. This length right here, z plus 8, is the mid-segment of this base side over here, 3z minus 10. So we know that the mid-segment equals 1/2 of that base side, right? Or, zoom out a little bit. Or I could say the base is 2 times the mid-segment. Let's just say ms. Okay, so how about we do that? We'll use this one. So the base is 3z minus 10. Change the color here. 3z minus 10. Let's substitute the expression equals 2 times the mid-segment is z plus 8. I'm going to do that in parentheses. So 3z minus 10 equals, now we're going to distribute this, 2z plus 16. Now let's subtract 2z. Let's get our z's together. So I get z minus 10 equals 16. And then we're going to add 10 to both sides. Z equals 26. So 26. And then if I put that in, 26 plus 8, that would be 34. And then if I put 26 in for here, 3 times 26 minus 10. 3 times 26. 78 minus 10 is 68. And 68 is twice 34. Okay, so it works, right? We want this base side to be double the mid-segment. Okay, so for x, you're going to follow the same thing. We know we can use this equation here. The base is 5x minus 18 equals 2 times the mid-segment, which is x. And so why don't we just do it? Subtract 2x to both sides. 3x minus 18 equals 0. Let's add 18. 3x equals 18. X equals 6. We divide by 3. So if I put 6 in here, I get 6. And then 5 times 6 is 30 minus 18, that is 12. Check, it works, right? Okay, so this next one is one that I really wanted to do for you guys. Let's take a look at, let's do the mid-segment one first. So we know that these are midpoints because look at the congruent segments that indicate that these are the midpoints. Boom. So we know that the base of the triangle is 2 times the mid segment, right? I think this is too thick. I think I need to just make it a little bit smaller. It's just a little too. And no. A little thicker. Can I get a 2? Let's get, how about 2? Yeah, okay. So what's the base? 8x squared minus 2 equals 2. Always use parentheses when substituting. It's generally a good idea, because we don't want to forget to distribute the 2 into the entire expression. 8x squared minus 2 equals 4x squared plus 2. Okay, what do we got? I just have x squareds here. Okay, how about let's subtract everything to the left. So that gives me 4x squared minus 2 equals 2. How about let's subtract this 2 over here. Now, the form we're looking for here is standard with a quadratic. And we write it in descending order, highest power to lowest power. This is power of 2. This is a power of 1. And this is a power, this constant right here, which I should say is a power of 0, equals 0. And it's really nice if that leading coefficient is 1. In this case, it is 4. So is it possible to get rid of the 4? Well, we can divide out something, and it just so happens that we can divide 4 out, and that is super nice. Just divide out the 4. You can divide a number out as long as it's not 0, and that you're doing it to every term in the equation. So next line, x squared minus 1 equals 0. Now, this is the difference of squares. Difference meaning subtracting, and perfect squares, right? So x squared is, is a perfect square, and 1 is a perfect square. So we're going to factor this into 2 binomials, and what happens is the middle term is canceled. There is no x term here because we have, this is called a conjugate pair. So x times x is x squared. X times negative 1 is negative x, and 1 times x is positive x. So when we FOIL this, I said x squared minus x plus x minus 1 is our last term here. And look, the middle terms are gone, and it leaves us with x squared minus 1. So this was the correct factoring of this quadratic, and x plus 1, we're going to set this one equal to 0, and then this one over here, x minus 1 equals 0. So our final answer is x equals negative 1 or positive 1. And either or both work. So when I put 1 in, I get 8. So I get 1 squared is 1. All right, so I just write it. We do exponent first. 1 squared is 1. 8 times 1 is 8. Minus 2 is 6. This is going to be 6. Let's do it here. 2 times 1, okay, 1 squared is 1, times 2 is 2, plus 1 is 3. So this is going to be 3, and that's going to be 6. That checks. The midsegment is half the base. If we put a negative 1 in here, we get the same thing because when we score a negative, we're going to get positive 1. So they both work. It really checks out, right? Now, let's take a look at this z here. Now, what do we know about those two segments? They're equal. So that means we could say, let's get a good color here. Let's go moss. Z squared minus 22 equals 9z. Okay, again, quadratic. Let's get this in standard form. Now we get a factor. What are the factors of z squared? Okay, z and z, right? What are the factors of negative 22? Factors of negative 22 that add to negative 9. This middle term right here. Anybody know? Well, the only factors of 22 are 1 and 22, 2 and 11, right? Those are the only factors. And so negative 22 means we can have a negative 1 and a 22, or a positive 1 and a negative 22. Either way, we don't get negative 9. So it's going to be this one, right? We're going to do a negative 11 and a positive 2 is going to give us a negative 9. If I switch the signs, it would be a positive 9, right? Okay, so we're going to get z plus 2, z minus 11. So we're going to take each one of these binomials, set it equal to 0, and solve. What value of z gives us 0? Well, negative 2 and positive 11. A negative 2 doesn't work here because I'm going to get a negative segment length. 9 times negative 2 is negative 18. None of it works. It's going to be 11. So if I put 11 here, 9 times 11 is 99. And then 11 squared is 121. Minus 22 is also 99. So that works. And I just got a call for Zoom. So I'm going to pause. In the back. And number 14. Perimeter of x, y, and z is 28. So perimeter is the distance around this object is 28 centimeters. We're looking for the value of n. Well, this is a midsegment, this is a midsegment, this is a midsegment. These three are midsegments. And if we were to add up the midsegments together, it would equal half of what all of the triangle sides equal to. They equal half. What's the total on the sides? The perimeter, 28. So that means that n plus 2n plus half n equal 14. And 3 and a half n equal 14. So how about we make this an improper fraction? 2 times 3 plus 1, 7 halves. N equals 14. How do we solve for n? We multiply by the reciprocal to clear the fraction. 2's gone, 7's gone. 14 divided by 7 times 2. Well, 14 divided by 7 is 2. 2 times 2 is 4. Or we could do 14 times 2 is 28 divided by 7 is 4. N equals 4. So I must mean that that's 4, that's 8, and this is 2. 8 plus 2 is 10, plus 4 is 14. 14 is the perimeter of this triangle. 28 is the perimeter of this one. All right, moving on. Okay. 17. Construct the midsegments of triangle ABC. Alright, what do we have here? Okay, so what is a midsegment? It goes, it's a segment whose endpoints are on the midpoint of the triangle. So we need to find the midpoints of each side of this triangle ABC, and the way we're going to do that is we're going to construct a perpendicular bisector. So I need 2 arcs. It goes at least halfway across the segment. So I'm going to do perpendicular bisector on segment CA, except I'm not going to draw the perpendicular. I could, I'll just do it lightly here, but really I just want the midpoint. Just want that midpoint right there. So I don't really want the perpendicular. So those are congruent. Let's call that X. I'm going to do one now. From B to A. Now, make that just a little bit longer here. Okay, so my intersections now. There, 2 above and below segment AB. And just want the middle. Call that Y. Put some double hashes on that. Now I gotta do, let's make my compass a little smaller. Okay, 2 intersections, one above and one below segment BC. Right there. Z. So Z to X to Y. So I'll put a single on that one, triple on that one, double on that one, parallel. This is not part of the construction necessarily, but why not? Let's label what we know. And triples on this one. Okay. And that's it. Okay, next one. Given the midsegments of triangle ABC that make triangle MID, find ABC. Okay, so this previous one, triangle XYZ, are the midsegments of ABC. Now this is MID. These are the midsegments of a bigger triangle. So we have to find the larger triangle that this one is the midsegment of. So don't find the midpoints here and connect that. That's not right. So what do we know? We know that a midsegment is parallel and half the distance of the base side. Okay, that matches with all of the midsegments. So let's do this one right here. M to I is going to be parallel to some segment that goes through D, where D is the middle of this segment, and this segment is going to be twice this one, right? So parallel, we need to make parallel line through point D that's parallel to MI. So we've done parallel lines before. So how are we going to do that? So how about this? Let's measure the distance from M to D with our compass, like that. And let's come over here and let's make an arc over here. Now, there's going to be a point on this arc that will be there will be a point on this arc that'll be the same distance from I as D is from M, right? This distance right here, somewhere. Now we need the point to match up with the same distance from M to I as D to something here, right? So what I could do is I could measure this length here from M to I and come over here and see how far away it is from D. Ooh, right there. See? So this is a way that we can construct a parallelogram. And we did this similar thing with the rhombus method for finding parallel lines. And so here I go right through D, and I'm just extend it on this side. And so this length here is the same as this length here. So I'm just going to take this same length and count it back to this point here. And so this is going to be my end point. I'm going to call it, how about AB? A to B. Now, how do we get C? Well, pretty easy actually, because I know that this point here is an end point of this side, and I know that M is the midpoint, so it's got to go somewhere this way, right? And then B is a midpoint on this other side of the triangle, and I is the midpoint. So I'm just going to extend both of these and find where my intersection is. So right here, that has to be C. So these two sides are parallel, and this is twice the midsegment. These two sides are parallel, and then this is going to be congruent to these two. So this is twice that. And then let's go triple. Of course I do triples on the smallest one. Not a great plan, but it's alright. Okay, there it is. Alright. Hope that makes sense. Should I do, maybe I'll do, alright, 15 and 16 here. Given the vertices of ABC, find the midsegments. Okay, so 5, -2 is A, 9, 4 is B, and C is -3, 8. Okay, so that's our triangle ABC, and we want to find the midsegments. So we're not going to do construction for this. We're just going to use some coordinate geometry. So I can find, let's find AB. So the midpoint of AB is going to be, so what's a midpoint formula? x1 plus x2 over 2, y1 plus y2 over 2. So AB, I've got A is, x1 is 5 plus 9 divided by 2. And y1 is negative 2 plus y2 is 4 divided by 2. So this is 14 over 2, and this is 2 over 2, and that gives me 7, 1. Over 7, up 1 right there. That's the midpoint, and I'll call that x. So I know these two segments are congruent, right? Midpoint of B to C. Okay, B, that's x1 plus x2 over 2, and y1 plus y2 over 2. 14, oh, I did A. I need to do, of course, I'm going to get the same answer as I just did. Rewind. Let's just fix that right there. BC, okay, 9 plus, we're doing negative 3. Okay, this is y2 right here. 9 plus negative 3 and 4 plus 8. Sorry, so 9 plus negative 3, 6 over 2. And then 4 plus 8 is 12 over 2. So I'm going to get 3 comma 6. 3 comma 6 right there. And that is Z. Okay. And now let's get AC. So A, x1 is 5 plus, and then C we're doing negative 3 over 2. And then we're going to do negative 2 is y1 plus y2. 2 over 2 and 6 over 2. That's 1, 3. 1, 3. Good. I mean, if you're not on the segment, you made a mistake, obviously. X, Z, we'll call this Y. And then you actually have to draw the segments. Okay, so this would be a single with those singles. Let's go double, triples. All right. Why not? Let's just put everything we know. Okay. How's that look? Good. Next one. Given the midpoints of the sides of a triangle, given the midpoints of the sides of a triangle, find the vertices of the triangle. So this M, I, D is small. This right here is the midsegment of a larger triangle. Okay, so what do we know? We know that, let's do the easy one. This vertical segment right here is parallel to another vertical side that's going to go through here, where I is the midpoint of this side. That's the easy one. We also do this one. So we know that this slope is up 1 over 1, and I know that M is the middle. So I could, of this third side, I can go up 1 over 1, like this, and make a line, and it's going to go parallel to this side, but we don't know where the other endpoints are until we do the other parallel sides. So this one's down 1 over 1, So I'm going to have a parallel line going through D, where D is the midpoint. So let's go down 1 over 1. And then draw a line. And I've kind of drew a bad line. I drew a bad one there. I didn't like that one. Let's see. So let's get some more points here. Yeah. Okay. And then this last one's easy. It's just vertical. And you can see it's just on the y-axis right here. And so here are the intersections of all 3 parallel sides. And we're going to call this A, B, C. And I can get rid of, this is a bad eraser. That's just a little oxidized. There it is. Yep, so can you see the triangle? It's right here. Find the vertices. Alright, well how about we go one step more. 0, -6, -5, -1, and 0, 3. Alright, there it is.